back to section 3.2, this is where we stopped at on Wednesday. It was actually kind of a good place to start because we had just finished going over standard deviation and variance of a frequency set, which definitely took some time. So the coefficient of variation is the standard deviation divided by the average or by the mean, and we express it as a percent. We call it CVAR. So we can use CVAR to compare standard deviations when the units are different. Okay, so we're taking that standard deviation, we're going to divide it by the average, and then we're going to multiply it by 100 to get a percent. So we're going to do a few examples together. It says the mean of the number of sales of cars over a 3-month period is 87. The standard deviation is 5. The mean of the commissions is 5,225, and the standard deviation is 773. Compare the variations of the two. All right, so we're going to use this CVAR formula, which is actually kind of basic. The formula itself is not that bad. So I'm going to have, I'll start with sales. So sales versus commission. So I'll leave some space for commission. And then I've got sales. And I'm just using this formula here. So they will give you some information. So they gave us that the standard deviation is 5. So S is equal to 5. And they also gave us the average, which is 87. So that would just be the X with the bar over it is representative of the average. And so I'm going to have 5 over 87 times 100. So 5 over 87 times 100 would be the CVAR for the number of sales. So it's the standard deviation over the average times 100. So when I calculate this, I get 5.7%. And so when we multiply it by 100, we're just getting that percent. I should probably put a percent here as well. There we go. So 5.7% would be the CVAR for sales. Now I want to give you a moment to find the CVAR for commissions. They give you those two numbers. So they gave me the standard deviation as 773. They gave me the average as 5,225. Now I can just plug it into the formula where I have S over X, which is the average, times 100%, which turns it into a percent. So in this case, I'm going to have 773 over 5,225. I'll multiply that by 100 to get a percent. And if I do this correctly, I should get 14.8%. That is correct. Okay, so 14.8%. And then to compare the variations of the two, the commissions are considered more variable than the sales, and that is only because the commissions percent is higher. So I'm gonna write a little sentence there. I know I'm running out of room. I apologize. I think they need to give us more space when we're doing this. We don't have enough space, but that's okay. I'm just gonna write it off to the side. So commissions are more variable than sales because the percent is higher. All right, let's talk about finding the CVAR when they give you variance. So sometimes they're going to give you standard deviation, sometimes they're going to give you the variance to start out with. So if they give you the variance to start out with, to convert variance to standard deviation, we just take the square root. All right, so remember when our calculator gives us standard deviation and we want the variance, we can just square the number. But if we're given the variance and we want the standard deviation, we're going to take the square root. All right, so in this case, in this example, they're going to give us the variance and the average for the number of pages of a sample women's fitness magazine, and then versus the number of advertisements of the fitness magazine. So they're giving us the variance and of both of these, and of course they're giving us the average. So in order to use this formula, we actually want to convert our variance to standard deviation, okay? And it's actually not that bad. So my CVAR would be equal to S would be the square root of 23 because the variance is 23, but I can easily make that into standard deviation by putting the square root on it. And then my average is 132. And so my CVAR is going to be the square root of 23 over 132 times 100%. That gives me about 3.6%. Okay, so I want to give you a few minutes to find the CVAR for the advertisements. I'm going to start to show my work here. So I'm going to have the variance is 62. So if I want to find the CVAR, I need to convert that into standard deviation. So that would be the square root of 62. And then the average given is 182. And so I'm going to have the square root of 62 over 182 times 100%, which gives me, I think some of you have already done this, 4.3%. So this should be 4.3%. Okay, it's easy to make a mistake, right? I understand, but are there any questions on how to find those numbers? Okay, so which one would be more variable? It would be the advertisements because this number is larger than the number of pages. So what would be more variable would be the advertisements. And so you're really just looking at whatever number is higher to figure that part out. All right, questions on CVAR, because we're going to move on to the next topic. So 3.2 just has a lot of these little things, right? And the next is called range rule of thumb. And we don't use this very often at all. So I'm going to kind of go through it pretty quickly because the next part we actually do end up using and you have it on your homework. So the range rule of thumb just approximates the standard deviation. And basically it's saying you could take the range and you can divide by 4. And if the distribution is unimodal and approximately symmetric, then we divide by 4, then the approximate value for the standard deviation would be obtained. And so that's all that that's saying. It's not as useful because it's just an approximation, and it would have to be a symmetric distribution, which we're going to talk about on the next page in picture form, and I think that should help you. So the range rule of thumb can be used to estimate the largest and smallest data values of a data set. The smallest data value will be approximately 2 standard deviations below the average. The largest data will be approximately 2 standard deviations above the mean of the data set. For example, if I say the average or the mean for the data is 9.3, and the standard deviation using the range rule of thumb is 2.7, it is saying that the smallest data value would be about 3.9, and the largest data value would be 14.7. And so in this case, the average would be in the middle, and we're saying 9.3. So this average would be 9.3. And then one standard deviation would be represented from here to here. That would be one standard deviation. Actually, let me use the symbol. That would be one standard deviation. And this would also represent one standard deviation. And so there would be a range of values that lie in that one standard deviation to the left and one standard deviation to the right. And then we would have two standard deviations, and we would have the values that fall into two standard deviations, and that the smallest data value will be approximately two standard deviations below, while the largest would be approximately two standard deviations above. And so that would be like the 3.9 would be here, and the 14.7 would be there. This, like I said, this is just like a rule of thumb because we don't always have this perfect data set. Okay, which leads me to Chebyshev's theorem, which can be used for any distribution. Okay, so this one will actually, but it's not accurate because there are lower, sometimes there can be lower values and sometimes there can be higher values. Yes, that's a good point, Emery. Okay, so Chebyshev's theorem talks about the variance and standard deviation, which can help determine the spread dispersion of a variable. The larger the variance of the standard deviation, the more data values are dispersed. For example, if two variables measured in the same units have the same average, say 70, and the first variable has a standard deviation of 1.5, while the second variable has a standard deviation of 10, then the data for the variable will be more spread out than the data for the first variable. The proportion of values from any data set that fall within k standard deviations of the mean will be at least 1 minus 1 over k squared, where k is a number greater than 1. K is not necessarily an integer. Okay, so here is what this looks like. And so Chebyshev's theorem, I'm just going to put Cheb for short, is equal to 1 minus 1 over k squared. Okay, so we can find the number of standard deviations. That's just going to be k. We can plug k in, and that's going to give us the minimum percentage with k standard deviations. And so you can see here, let me put this here. So this is 1 minus 1 over k squared. Let me do that. Okay, so for example, if k equals 2, then 75% would be the minimum percentage with k standard deviations. And the way we find that is just that 1 minus 1 over 2 squared. So that would be 1 minus 1/4, which would be 75%. If k was equal to 3, which is shown right here, it would be 1 minus 1 over 9, which would be 8 over 9, which would be approximately 88.9%. And then for standard deviations, of course, would be 1 minus 1 over 16, which would be 15 over 16, which would be 93.75%. To find the range of values using Chebyshev's theorem, you can use the average plus or minus k sub s, or if you separate the formula, the lower value is just going to be x, the average minus k sub s, and then the upper value is the average plus k sub s. Okay, if you're more of a hands-on learner, you might need to see this in a specific example. All right, so that's just like the general definition, and I'm now going to do an example of specifically what this would look like. So let's do an example together. It says, for the example in which variable 1 has an average or a mean of 70 and a standard deviation of 1.5, at least 3/4 or 75% of the data values fall between 67 and 73. These values are found by adding 2 standard deviations to the mean and subtracting 2 standard deviations from the mean as shown. Okay, and so they've already done this for you, but I want to show you what this looks like as well. So we can use the fact that the average is 70, so the average, or the mean, is 70, and we're going to go 2 standard deviations from the standard deviation of 1.5. So they did 2 times 1.5. That would be 70 plus 3, which would be 73. And then 70 minus 2 times 1.5 would be 70 minus 3, which is 67. And so if you think of it in like a picture format, if I had the average of 70, then 1 standard deviation to the left and 1 standard deviation to the right would be 67 and 73. I'm sorry, that would be 2 standard deviations. Hold on, because it's 1.5 away. So that would be 2 standard deviations, which is what this was wanting us to find. So 2 standard deviations would be plus the 1.5 here, plus the 1.5 here. So this would be 71.5 would be 1 standard deviation away, while 3.0 would be 2 standard deviations away. And on the left, the same would be true. I would have 1.5 here and another 1.5, which would be, this would be a total of 3. And if I go 1 more, that would be a total of 3. And what this theorem is stating is that 75% of the data values would fall between 67 and 73. And this is a theorem, but it does work with other distributions as well. All right, now we don't have, it's not like they're giving us all the data. They're just asking us to figure out, okay, according to Chebyshev's theorem, then what would those values be? And so in this case, it would be from 67 and 73. All right, so let's try another one. And it looks like if you have extra time, there are a nice example of this theorem in practice, finding the lower and upper bound. And it looks like there's some things you can do with your calculator as well. All right, so let's try the price of homes. So the average price of houses in a certain neighborhood is $50,000. The standard deviation is $10,000. Find the price range for which at least 75% of the houses will sell. Okay, so 75%, if you remember from that table with Chebyshev's theorem, we're talking about 2 standard deviations. 2 standard deviations for 75%. So let's see. We're going to have our average, and we're going to use that formula. So it's the average plus KS, where K changes based on the percent. And in this case, because it's 75%, again, it would be 2. This one, all right, so we have our average, which is 50,000. So our average is 50,000. And then our S is our standard deviation, which is 10,000. And they are asking us about 75%. In this case, that would be K equals 2. All right, so I'm going to find the low and I'm going to find the high. And there is more than one way to do this, or one way to think of this, okay? But I'm going to follow the formula because that's how they want us to do it. But then I'm going to show you the other way as well. So if I have 50,000 is my average, I can do minus 2 times the standard deviation, which is 10,000. So that's going to be 50,000 minus 2 times 10,000, which is 30,000. And that's going to give me that low value. To find the high value, I'm going to do the same thing, except for I'm going to add instead of subtract. Which I almost forgot to do. So I'm going to have 50,000 plus 2 times 10,000. So that higher value would be 70,000. And that would mean that at least 75% of all homes sold in the area will have a price range from 30,000 to 70,000, according to Chevyshev's theorem. And if you want to think of it as like on a number line, our average is 50,000. And then if I go 2 standard deviations to the right, that would be 10,000, which would be 60,000 would be 1 standard deviation. And then if I go 1 more, that would be the 70,000. And that would be another way to get that number. So I go 10,000 to the right twice, that's going to give me 70,000. If I do the same thing to the left, I go 10,000, that would be 1 standard deviation, which would be 40,000. And then if I go 1 more, that would be another 10,000, which would be 30,000. So that range would be 30,000 to 70,000. All right. Now, another thing that they can do is they can give you the percentage values, and then you're actually going to have to solve for the K. All right, so let's see what that looks like. So that actually is on this next example. So a survey of local companies found that the average amount of travel allowance for executives was 0.25 cents per mile. So that's our average. And the standard deviation was 0.02 was our standard deviation. Using Chevyshev's theorem, find the minimum percentage of the data values that will fall between 0.20 and 0.30. Okay, so we're actually going to use that same formula, but we are given the low and we're given the high value. And we're going to try to figure out what that K is equal to. Okay, so I'm going to do this in red. So we'll start with the high. So remember, the high is equal to the average plus KS. The high in this case is 0.30. So this is my high. So 0.30 will go here. The average is 0.25. And then we have plus K times the standard deviation, which is right here at 0.02. So that's my formula set up on the high value. Now for the low value, which I'll do off to the side, and then we can solve both of these. For the low value, I've got the average minus K times S. But my low value is 0.2. Let me do this in a different color. Okay, 0.20, which is right here. That's my low, is equal to the average, which is 0.25, minus k, which we're trying to find, times 0.02, which is the standard deviation. So just remember, this S is the standard deviation. All right, now I'm going to solve this. I'm going to try to get k by itself. So I'm going to subtract 0.25 from both sides first. And that would be 0.05 is equal to, and then this is just k times, I'm going to write that as 0.02k, because that's the same thing. I'm just rearranging it. And then I can just divide both sides by 0.02. And that gives me 2.5. And I'll give you a moment to solve the second one. If you solve the second one correctly, you should get the same answer for k. You should get 2.5. All right, so I'm going to subtract 0.25 from both sides, and I get negative 0.05 is equal to, and then this is negative 0.02k. I just rearrange it, and then I divide by negative 0.002. And I get 2.5. Okay, now Chebyshev's theorem states that we can now take the 2.5, which before we had 2 and it was 75%. 3 is like 88.9%. So 2.5 is going to be somewhere in between those two numbers. And so to figure out the actual percents, so Chebyshev's theorem is equal to 1 minus 1 over k squared. This time k is 2.5, so 1 minus 1 over 2.5 squared. So I'll give you a moment to find that number. If you do it correctly, you should get 0.84, which means that at least 84% of the data values fall between 20 cents and 30 cents. Now, we don't have to necessarily understand how Chebyshev's theorem is derived or how it works. If we had a whole lot of time, we could probably play with some numbers and really try to extend that farther, why Chebyshev's theorem works. We just need to know how to apply Chebyshev's theorem. And remember, you don't necessarily have to memorize any of it because you are allowed to use your notes. And even in an in-person classroom at our school, our students would have a formula sheet, and then they would be able to write some other stuff on the other side of their paper. That's really hard to do in a remote situation because it's more like this to try. Yes, perfect. Okay, so I want to give you a moment to, actually we have a few more. I'll give you a moment to please try Chebyshev's theorem to solve the distribution with a mean of 80 and a standard deviation of 10. Then at least what percentage of values would fall between 60 and 100, and then 65 and 95. So I'll give you a few moments to try this, and then of course we'll do it together. All right, for the sake of time, I'm going to go ahead and get started with number 1. So for number 1, I am given the range of the percentage given the range, we're going to try to figure out the percentage, all right? So I'm going to be using the same formula we've been using. I'm going to start with the x-min value, which in this case I could write as the average plus KS, and the average is 80, and the standard deviation is 10. So this time, whenever I plug in 10 for S, I'm just going to write it as 10K to make it simpler to solve, and my minimum value is 60. So that would be my first equation, or one of my equations, I should say, because the order doesn't matter. You can do the minimum or the maximum. And what's kind of cool about this is if you do it right, you should get the same value for K. And so if you do both equations, that's actually a good way to check to make sure you're on the right track. Okay, so that would be one of my equations. My other equation you could possibly use, and like I said, you really only need to do one. Oh, you know what? I'm sorry. Let me backtrack. Sorry about that. I said min, but I put a plus. Did you guys notice that? It's okay. I'm going to fix it. Okay. And I don't know why that's like super thick all of a sudden. So let's do the average minus KS. And so that would still be 60, but it's going to be the average, which is 80 minus 10K. Okay, so that's one of my equations. That would be for the minimum. And then for the maximum, I would do X max, which would be the average plus KS, and my max is 100, my average is 80, plus the standard deviation, which is 10, so that would be 10K. Okay, so as long as you have one of these equations, you should be good, because you really only have to solve one to get the answer. But if you do both, you should get the same answer, and that's always a good sign. All right, now are there any questions on how I came up with, or how I'm using the formula? Like where my numbers are coming from. Okay, so now I'll solve. I'm going to subtract 80 from both sides, and that gives me negative 20 is equal to negative 10 times K. Divide both sides by negative 10, and I get 2. K equals 2. And then I could do the same thing over here. I would subtract 80, and I would get 20 is equal to 10 times K. Divide both sides by 10, I end up with 2. Either way, I get K equals 2. But it is asking me for the percent of values. So once I have that, I'm going to use Chebyshev's formula, which is 1 minus 1 over K squared, which is 1 minus 1 over 2 squared. Now we've seen this before in our table. It is going to be 75%. If K is equal to 2 for Chebyshev's, it's always going to be 75%. You don't even have to do this part if you have that memorized. Or if you just simply write that table in your, like on your little note sheet. So I end up with 1 minus 1/4, which of course is 3/4, which gives me 0.75, which I turn into a percent, and I end up with 75%. Okay, so this was 0.75, which turns it into a percent. You may have noticed that if you think of it number line wise, here's 60 and here's 100 and the average is 80, and the standard deviation is 10, then one standard deviation would be 90. So that would represent one standard deviation, and then another standard deviation would go from 90 to 100 because it does differ by 10. So one standard deviation would be plus 10, which gives me 100. And then the same thing is true here. I would have minus 10, which would be, of course, 2 standard deviations. And so you may have been able to almost estimate it just by thinking about those numbers. The fact that 80 is in the middle, and then I would have plus 10, and plus 10 would be 2 standard deviations. But sometimes we end up with a decimal, which is what we're going to get on the next one anyways. So it's actually good to use our formulas. All right, so let's go ahead and try number 2 now. So number 2 is similar. I'm going to only do one equation this time because, it gets a little redundant. So I'm going to use the x max. The x max is 95. So 95 is equal to, and then the average, which is 80, plus ks, where the standard deviation is 10. So it would just be 10k. So I have 95 is equal to 80 plus 10k. The other equation that you could have used is 65 equals 80 minus 10k. But either way, we're going to get the same answer for our k. All right, so I'm going to subtract 80, which gives me 15 is equal to 10 times k. And then I divide both sides by 10. And I end up with k equals 1.5. And I don't have that one on my table because it's a decimal. So I'm definitely going to use the 1 minus 1 over k squared formula. Okay, and like I said, I apologize that I'm running out of room. It's a little frustrating. So I'm going to have Chubb's formula 1 minus 1 over 1.5 squared. I'll give you a moment to type that into your calculator. I'm going to double check with mine even though I already have it written down. So 1 minus 1 over 1.5 squared. And I get approximately 55.5%. And depending on how they want you to round, so they might say like round to the nearest percent, but you get about 56%. I'm gonna say 56 because I think they want us to round to the nearest percent. So we'll say 56%. 55.5, we're gonna round up to 56. They're probably gonna ask you for the full percent there. All right, so there is a question that is similar to your homework, and this is the last one on Chevyshev's theorem. It should be. It's like we spent a lot of time on this. Okay, so sale price of homes. The average sale price of a new one-family house in 2003 was $246,300. Find the range of the values in which at least 75% of the sale prices will lie if the standard deviation is 48,500. All right, so we're going to use Chevyshev's formula to help us to find the range of the values. Okay, so this is using the formula in a different way, and we are going to use the fact that the average is $246,300 and that the standard deviation is 48,500. Since we have this 75% of 75%, I want you to type into the chat if you know what I'm going to use for K, because we see this over and over again. 75% is very popular. Okay, good. You guys are getting it. We're going to use 2. Okay, good. So K is equal to 2. I'm going to put C chart if needed. All right, so if they ask for 75%, you should be thinking 2. All right, cool. So I'm going to find the low or the min. I'll put low this time since I've been using min and max a lot. And I'm going to find the high. And I'm just going to use that same formula over and over again. So it's going to be the average and then minus KS, the average plus KS. I want to give you a moment to try to find those two values using this information. Remember, K is equal to 2. Done. I can see by the chat. Okay, so let's go ahead and plug in our numbers. So we've got the average is 246,300. And then minus, we have the K, which is 2. So 2 times 48,500. And then I'm going to do something similar down here for the max. I'm going to have 246,300 and then plus 2 times 48,500. Okay, so once I calculate that, I think it is unanimous that we end up with 149,300 for our low and 343,300 for our high. So 149,300 to 343. And so that would be the 75% of Chebyshev's theorem of where that would be located at, what those values would be. Okay, and then, oh, perfect. All right, so, oh, gosh, sorry. I lost you guys for a second. That was weird. We're going to talk about one more thing, and then I'm going to show you a few of your homework problems that are towards the end of your homework that I want to make sure we're on the same page. Okay, is it okay if I click? You guys good? Okay, awesome. So let's go ahead and move into what we call the empirical rule, which is also normal. So Chebyshev's theorem applies to any distribution regardless of its shape. However, when a distribution is a bell-shaped, or what we call normal, the following statements which make up the empirical rule are true. So this is the empirical rule, that approximately 68% of the data values will fall within one standard deviation of the average, that approximately 95% of the data values would fall within 2 standard deviations of the average, and then approximately 99.7% of the data values will fall within 3 standard deviations of the average. Okay, and this only occurs when the distribution is bell-shaped, or what we call normal. And then we have this percent for you, that this table would also help you quite a bit. So if it's normal bell-shaped, once again, if k is equal to 1, which would be 1 standard deviation, 68% of the data should fall within 1 standard deviation, 95% should fall within 2 standard deviations, and then 99.7% would fall within 3. And so when you hear the word normalize, when they normalize the data, like for a test, then they are possibly curving the test so that it falls into this category of the standard deviation idea. So what I want to do is I want to show you one of your homework problems, and then we're actually going to have an exit ticket today because I want to make sure we're all on the same page. All right, so hopefully you got 355 to 649. All right, and when you think about that distribution curve here, I'm going to try to draw this best I can. Okay, so here's my average. My average is 502. And then for my standard deviations, I would have, we're talking about 3, so about right here, 3 standard deviations. So let me draw a line here. Okay, so 1, 2, 3. Okay, and then this would be 49. So plus 49, plus 49, plus 49. And so 502 plus 49 would be 551. And then if I add 59 to that again, I get 600. And then if I add it one more time, I get 649. So that's what it would look like visually. And I'm going to show you this because of part 2 of your homework question that's a little ridiculous. Okay, so that would be on the right side. On the left side, it would be very similar. So 1 standard deviation would be to the left by 49. So 502 minus 49, which is 453. That would represent that 1 standard deviation. 2 standard deviations, I would subtract 49 again. That would give me 404. And then, of course, you already found for 3, which would be 355. Keeping in mind that each of these represents, a standard deviation between the numbers. Okay, so the reason why I wanted to show you this is because the other question that they're going to ask you on that homework assignment is, so it's going to be part 2. You know how they like to ask you multiple parts. Okay, so the part 2 of this question is at what percentage of scores would be above 600? So let me write that for you. So what percentage of scores would be above 600? All right, so I want to give you a moment to think about this, keeping in mind the table that might help you with what that percent would be. Okay, so I want to give you a moment to think about it. All right, for the sake of time, I'm going to go ahead and start talking about this. Okay, so let me explain. And I'm going to try to do this with some shade here. Okay, so from one standard deviation is 68% proportion within K standard deviations. Okay, so 1, this would represent this shade from here to here, which is 1 standard deviation away, is 68% of the data values. All right, 2 standard deviations away is 95%. And if you look at the 95%, so for 2 standard deviations, I'm going to do this in blue, we're talking about these values. So 95% of that would be in, from 404 to 600 would incorporate 95% of the values. Okay, and then 3 standard deviations, of course, is the 99.7. So 3 standard deviations would be from 355 to 649, which we've already kind of found that. So what would be greater than 600? Well, so here to here, this is 95%. So if 95% of the values are in between 404 and 600, then what percent do you think would be above 600? Okay, a lot of you are saying 5. Good. Okay, you're understanding a little better, but you are so close. Okay, the reason why is because there's a left side and there's a right side. All right, so above 600 would actually be 2.5%. Now, if it said less than 404 and more than 600, it would be 5%. But since it's only asking for above 600, and this whole part here is 95%, right? This whole part is 95%. We have a little tiny slither over here, and we have a little tiny slither over here, which would represent 2.5% and 2.5%. Okay, so that is 2.5%. I know, it's crazy, right? I thought that question was a little bit over the top. Okay, so